Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the editorial director with Data Science Central and also chief data scientist for Data Magnum. So I'd like to start off our event today by thanking Trifacta for sponsoring today's event. Trifacta is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled Harness the Power of Big Data Analytics, and that'll be presented by Trifacta. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have two presenters who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation, and this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. So I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speakers, Raju Penmacha with Data Robot and Connor Carreras with Trifacta. Now, Raju has a PhD and is a customer-facing data scientist at Data Robot with close to 20 years of experience in modeling, analytics, and technology. Raju's worked with companies such as American Express, HSBC, and the Mayo Clinic on a variety of data science use cases, including recommendation systems, anti-money laundering, and big data security. Now, Connor is Trifacta's manager for Customer Success Americas, where she helps customers use cutting-edge data wrangling techniques in support of their big data initiatives. Connor brings her prior experience in data integration space to help customers understand how to adopt self-service data prep as part of their analytics process. She's a co-author of the O'Reilly book, Principles of Data Wrangling. So Raju, Connor, hey, thank you so much for being with us today. We're looking forward to your presentation. From BI to AI, the needs for big data and analytics is pervasive and transformational. However, big data technologies such as Hadoop or Spark are still quite complicated and not leveraged to their full capacity for business practitioners. New technologies are available to leverage the power of big data platforms for self-service data prep and automated machine learning to help organizations get the most out of their analytics and unlock the full potential of their big data investments. So in today's Data Science Central webinar, you'll learn the essentials you need for a modern data and analytics strategy, ways to expand your strategy development repertoire, and emerging approaches, as well as why big data solutions like Hadoop and Spark are ideal for machine learning and advanced analytic initiatives, what automated machine learning for big data is and how it can change your approach to machine learning, how self-service data prep reduces the work required to deliver clean data at scale for predictive modeling, and how to leverage big data platforms to rapidly deliver more accurate predictions for machine learning initiatives. So, Connor, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
All right. Thanks so much, Bill. So, as Bill said, today we're going to be focused on how Trifacta and Data Robot, so data preparation and guided machine learning, can help you harness the power of your big data analytics. So, I think most people in the data space are familiar with the concept of a data lake and really the promise and the hope of a data lake, which is a space where you can serve your business users, your data scientists with beautiful data, allow them to access for their projects and ultimately, make use of that for machine learning and analytics. Now, sadly, the reality looks a lot more like what we see on this slide. Instead of being an open platform, often data lakes seem somewhat frozen over. It can be challenging for the promise of the lake to be fulfilled and for the end users, the business users, or the data scientists to actually make use of the data in the lake. Now, why is that? Part of the challenge is that the traditional tools that have served big data platforms or data lakes have been highly technical in nature, and this can often make it challenging for the majority of users in an organization to really leverage the data in the ways that they want. So what we've seen is the data lake vision is somewhat immature in organizations. So we wanted to start right off with making things interactive. So what you should be seeing on your screen is a poll, and you can go ahead and start answering as soon as this comes up. Just click your answer. We wanted to get a sense for what your data lake strategy looks like. So do you have plans for a data lake now? Do you not have any plans at all? Are you kind of in the early stages of thinking about how you can set up a data lake? Or, are you building out a small set of initiatives in your data lake? Or even maybe there's some people on this call who have an enterprise-wide data lake already. So we'll just give you guys a couple minutes to click one of these responses. All right, so let's see what the group is thinking. Okay, so it looks like roughly half the group doesn't currently have plans for a data lake. The other half is, early stages of thinking about what a data lake can be and what the benefits are. That maps pretty closely to what we've seen when working with customers at a lot of our big client engagements. So this slide should also be somewhat familiar. It's not to scale, just some estimates. But when you're thinking about your organization and the data professionals who are working at your company, the largest chunk of people who work with data are data analysts, business analysts, or SQL analysts. Any data scientists on this call are probably familiar with being called unicorns because that's a very rare specialized skill set at most of these large organizations. So if you think back to our frozen over data lake, part of the challenge, part of the reason that those lakes can be frozen over is just that there's so few data scientists and data engineers in relation to the entire data community at a company. So what we've mapped here on top of our charts, again, not to scale, are the technical skills. So in the slightly darker color, you've got the level of technical ability related to the percentage of people in the organization in each group. So what you'll notice is that the most technically skilled people, the data scientists, the engineers, the analysts, are often the least visible or have the smallest numbers in an organization. So if you're really trying to leverage data science enterprise-wide, that can be very tricky. So where Trifacta and Data Robot come in is actually helping you close that skills gap, helping you make data science, machine learning accessible to the full group of data professionals at your company. So what you'll see here, of course, is that those dark shaded bars have filled up entirely. And this is really helping everybody be able to access the power of machine learning and AI. So Raju, do you want to talk about the legacy process?
Yes, Connor. Thank you for that. I appreciate it. So as you can see in this slide, the legacy data modeling pipeline looks as follows. Data is ingested from various sources into a data lake. This work is done mostly by data engineers and SQL analysts. After that, data is prepped and models are built in here. And that work is done mostly by data scientists. The third step is where the final model is pushed into production. Model monitoring also happens here. This work is, again, done by data scientists and data engineers. And the fourth step is where business makes use of these predictions, right? As you can see, there is a huge dependency on several actors and quite a bit of dependency on data scientists. Now, the modern way of building this data pipeline and an efficient way is to empower business users through self-service tools. As you will be seeing soon today, tools such as Trifacta and DataRobot can help business users to handle boxes 2 and 3 shown here. So that way, instead of waiting for a data scientist or a data engineer to be available for your project, a business user can start using these tools and start building predictive models on their own. So Trifacta helps you with the data preparation, while DataRobot helps you with modeling work. So we will show you today how these tools will simplify all of this for the business users. Please also note that the model accuracy and outcome is only as good as the data that is supplied to the model. So in the next few slides, we will discuss automated machine learning and DataRobot. Here is a famous quote from Elon Musk. He says, companies have to race to build AI, artificial intelligence, or they will be made uncompetitive. Essentially, if your competitor is racing to build AI, they will crush you. So in summary, he's asking all companies to get into AI or be prepared to be crushed by your competitor. In this slide, the plot here shows you how demand for data scientists would outpace supply. And so this is the demand. The blue line versus this is the supply. And the way to fill this gap is to either increase the productivity of data scientists or enable citizen data scientists. And today we will show you exactly that. Some details on DataRobot as a company. We are founded in 2012. We are well funded. And so far, more than 500 million models were built by our users on the DataRobot platform. We have more than 200 data scientists and engineers out of an employee base of more than 350. 4 of the #1 ranked data scientists are on Kaggle at one point or the other work at DataRobot, and they had finished in the top 3 more than 50 times on Kaggle. We serve verticals including insurance, banking, healthcare, fintech, and many more. In this slide, you see a Venn diagram that shows you all skills required to create this unicorn called data scientist. It requires programming skills. It also requires math and stat skills and domain expertise. It's impossible to find many people that have all these skills. So how can you solve this problem? Well, DataRobot's automated machine learning platform requires no coding skills for the user and no math or stat skills. So anyone that's a business analyst or an engineer or an executive can start using this platform and act like a data scientist. So we have a few questions that will pop up to you right now. I will read those questions. AI are vowels and machine what? No plans. We are not experts, but interested in learning about AI, ML for our business. We have a team getting started with AI and ML. We are AI ML experts and have a growing set of initiatives. So we'll give you a couple of minutes to answer those questions. All right, looks like we have some answers here. So a lot of people have heard of artificial intelligence and machine learning, so that is great. About half of them say they are not experts, but they are interested in learning about AI and ML for their business, which is exactly what we are seeing outside in the marketplace. And about a third is getting started with AI ML, and there are about 10% who are very good in AI ML already. With that, I will pass it back to Connor to give a demo on Trifacta.
Thanks. So Raju has given a really great overview of the value of AI and ML for your organization, and particularly how DataRobot can help you expand the group of business users who are able to really leverage AI and ML. Now, of course, in order to build good models, you need to first have good data, good training sets, clean data, the right features. So you've probably seen the 80% number before. This has been around since about 2011. I think DJ Patil made this percentage very popular in the industry. But it's basically 80% of time spent in an average data science project is really spent doing data preparation and data cleansing. So the fun, jokey quote from the Kaggle founder is that 80% of data science is cleaning the data and 20% is complaining about cleaning the data. So traditionally, the data prep and data cleaning process has not been something that data professionals look forward to at all. I've heard this called data munging. I've heard it called data janitorial work. It's traditionally been not fun, takes a long time, very unsexy. And that's exactly the problem that Trifacta has been created to solve. Our product is all about helping you reduce that 80% time that you're spending cleaning data and be able to actually, I like to say it's fun to clean data in Trifacta. Take that with a grain of salt, but really the focus of Trifacta is around empowering people, improving efficiency, and aligning with enterprise IT. We believe that those three pillars, which you'll see in our product a bit later, are what allows you to spend much less than 80% of your time in a project cleaning your data engineering features, and actually a lot more time deriving value out of your data sets and creating predictive models using tools like DataRobot. So I have the obligatory slide about Trifacta. We are the established leader in the data preparation market. We've received #1 rankings from media and analysts over the course of our time in market, and also a large number of enterprise customers, a number of those shared with DataRobot, as well as wide support for cloud platforms and well integrated with the broader analytics ecosystem. So the next question that you're going to see popping up in a couple of seconds is around your data preparation process. So we want to get a sense for, are you doing data preparation today? And if you are, what does that look like? Are you still in the old school method of data preparation where you're spending months really trying to get your data ready with a large dependency on the IT team to do a lot of this work for you? Are you mostly working in Excel, doing manual processes, kind of eyeballing your data and trying to hope and pray that you're finding all of the outliers and unique values? Or do you have a well-established practice for self-service? So I'll give you guys a couple minutes to click your answer, and then we'll take a look at the results. I think a lot of what we've seen in the past is that the majority of customers seem to have a fairly well-established practice, but for whatever reason, it needs modernization or can benefit from deploying more contemporary tools to really accelerate that process. And interestingly, it looks like this group is no exception. We are seeing that roughly about half of you are looking to modernize that data prep process. So before we jump into the demo, we wanted to show you how all of the pieces of this fit together. So you got a brief introduction about data lakes, talked about data preparation, talked about machine learning. So how do all of these elements slot together into a single unified platform? What you'll see as soon as the slide progresses is a diagram just putting all of these pieces together. So, of course, at the bottom you have your data sources, moving into a shared environment where you can access those sources. We call this a data lake. It could simply be your systems of record, followed by a data preparation tool like Trifacta that allows you to transform, blend, clean, and feature engineer that data. And then, of course, passing the results of the Trifacta process into DataRobot. With that, I think we're going to jump into my favorite part of this webinar, which is actually seeing how these tools work and getting to experience live what Trifacta and DataRobot put together can do for your business. So in a moment, you're going to see the Trifacta interface. What this demo is going to show you, we've actually built this based on some real data sets from Lending Club. And these are historical data sets that provide information about member loans. So what loans did members end up having? Were there defaults? What were the characteristics? The goal of this machine learning project that we're going to put together today is to allow DataRobot to figure out a predictive model to be able to guess which loans are likely to default. So in order to do that, in Trifacta, we've started with two data sources. The first, of course, is that loans data set from LendingTree, which you'll see right here. And the second data set is our member info data set. So this is a secondary file. Often when you're doing a machine learning process or when you're engaged in feature engineering, it can be very valuable to enrich data sets with additional sources. So we're bringing this member info in so that we can maybe gain some interesting features about the characteristics of each of the people asking for these loans. So in Trifacta, you add a recipe in order to do all of your data cleaning and feature engineering work. So we're going to add a recipe onto member info. So when you open the recipe, which is what I've done right here, you can see the interface that Trifacta creates is intended to be extremely visual. So you see your data as you're working with it. what this allows you to do is significantly reduce the amount of time that it takes to understand, explore, clean, and prepare your data. On top of each column, we also automatically collect profiling information. So if you think of your data preparation process today, if you're using code to do this, if you're using Excel, a lot of times the profiling, exploration, and the actual transformation process are two separate processes. You have to write the separate code to profile the data, look at the profile, and then go back and write more code to clean the data, look at that result. Trifacta lets you see the profile and the data at the same time so that you can actually use the profile to inform all of the operations that you're doing to your data. So if we look at this annual income column, this is a really interesting column. The horizontal bar right at the top here, that's what we call the data quality bar. The data quality bar is based on the data type of a column. So in that case, this is a decimal column. And it tells you the number of records that are valid, missing, or mismatched in the column. So one of the most important things to do when you're cleaning data is, of course, making sure that all of the records, all of the values in a column are actually valid. So we can see immediately from the red part of this data quality bar that some of the values in annual income are not actually decimals. So Trifacta lets me drill in a little bit deeper and actually see what these values are so that I can correct them. So to do that, I can click on the mismatched values and simply filter my view down to see exactly what those records are. So this is letting me see in real time through exploring my data and exploring my profile exactly what these bad records look like. So in this case, I can see that the annual income column, it looks like this is probably human-entered data, because instead of putting a full number, people have actually just written 75K, 65K. So how do we clean this data up? Another benefit of Trifacta for really reducing that time to value is what we call predictive transformation. So this means I can select elements in the data that I want to fix, and Trifacta is actually going to propose suggestions for how to deal with that data. So I'm going to highlight the K. I'm telling Trifacta, okay, I want to do something with these Ks in my data set. And you'll see on the right side of the screen, Trifacta has produced a number of suggestions. And we're actually getting real-time previews that show me the result of all of these transformations. So I can click on each one. You can see this replace suggestion is saying, well, let's scrape off that K. And I can edit this a little bit. Maybe I want to find K and actually replace that with the correct number of zeros. Notice as I'm typing in the zeros, we are getting, again, in real time, the actual preview of what this is doing. So I'm cutting down my iterations. I'm making it a lot easier to understand exactly what is happening with each step. So I can add that to my recipe. And we've now cleaned up that annual income column.
Connor, excuse me, this is Bill. Your demo screen seems to have frozen. You might want to refresh that.
Oh, that's not good.
I expect it's the platform's problem. You might need to restart the screen share.
Okay, give me a moment. I'll stop the screen share and restart. All right, let's try this again. Sorry about that, everybody. Bill, any progress?
Oh yeah, we can see you just fine now. Thank you.
Okay, Great. So I imagine part of that was cut off. I think my colleague told me that it was after we had cleaned up, while we were attempting to clean the annual income column. So I will just reactivate my step so that you can see the preview I was talking about. So this is the actual text of that transform that I created. And if you look at the preview in my grid, the actual data, you can see these 75K, 65K rows that I was referencing. And on the right, the yellow colored column is displaying how the zeros are getting added back on. So an unanticipated benefit of this little technical blip is that you got to see how easy it is to edit steps in Trifacta, and at every point, go back and make adjustments to your logic and actually, regenerate all of those previews. So our next step here is enriching this data set. So you'll see at the top of the screen there's a handy toolbar. This provides users with a familiar interaction pattern, so something that you see a lot in Excel or other data tools. And these are some of our most commonly used transformations up our join interface. And I'll bring in that member loans data set. Remember, these are all the data about the loans that people have signed up for. I can preview this data set just to make sure that, this is the data I want to bring in. And then I'll choose my join keys. So another benefit of Trifacta for accelerating the data prep process is that Trifacta will try to infer the join keys for you. So if you've ever dealt with two large data sets with foreign key, primary key relationships that you may not entirely know, this can be a big time saver. So you'll see that Trifacta has correctly guessed that member ID is our foreign key. And you'll see that the key matches are displayed on the right. I can then select from the list of columns exactly which columns from my current data set and my joined-in data set I want to bring in. I'm just going to choose everything. And I'll leave the join type as an inner join. So when I click Add to Recipe, you'll see this join occur. Now, my final step here, we've done a tiny bit of data cleanup. We've done some data enrichment. Since the end goal here is to create an engineered data set that DataRobot can use to predict loan defaults, we need to create a target variable. So if we scroll through this data set, I'm actually going to search for the column I want, loan state. You can see that we've got 5 different categories of loan state. And I'm seeing this by looking at my column level histogram. That's these vertical bars displayed right under the column header. That's showing me I have 5 unique loan states. Now that's probably a little bit too much for DataRobot to predict. We want to really have just 2 variables, is a good loan or is a bad loan. So I can very easily create a condition to classify these values into 2 buckets. I'm again going to use the toolbar. In this case, I'll do a case on a single column. You'll notice that this opens up a very easy to understand builder interface. So this will just walk me through exactly what I need to enter in order to create my target variable. So I'm going to evaluate the loan state column. My first case is loan state is fully paid, and that'll be 1 or 0 because that is a good loan. I'll add a second case. We'll say my second case is loan state is current. That's also a 0, also a good loan. And my default value, so that'll capture everything else, all of the bad loan categories, which are charged off in grace period or late. I'll put those as 1. Notice my preview is showing me that there's about 150 of these bad loans in my training data set. We'll call this column is_bad. And when I click Add, I've now created my target variable to use in my prediction. So my final step, and of course you could do more cleaning, a little bit more feature engineering on this data set, but I'm ready to produce a file to feed into DataRobot. To do that, I'm going to click on Run Job. I can choose my publishing options. I'm just going to make a CSV in this case, and kick that job off. Now at this point, now that I have produced my CSV file. We are ready to pass that file directly into DataRobot and come up with some predictions. So Raju, do you want to take control and walk them through how to use DataRobot?
Yes, Connor, thank you for that. So as you can see, it's really easy to use Trifacta to handle data which could be otherwise very complex. And maybe you want to definitely give a try to Trifacta. So let me now bring you to the DataRobot platform. Give me a second for that. Okay. So you should be seeing the DataRobot screen now. So this DataRobot is a supervised machine learning platform that lets you build predictive models really quickly and very accurately. So just as Connor said that she had fun using Trifacta, I also have a lot of fun using DataRobot because of the ease of use and how quickly and easily I could build very accurate predictive models.
Raju, excuse me, this is Bill. You may need to relaunch your screen share. I don't believe we're all seeing your application yet.
Oh, is that right, Bill? Let me try that again. Bill, how is it now?
I am still not seeing your application. Connor, can you see DataRobot's application?
No.
It looks like we have a loading state.
Okay.
Maybe we can give it another 5 seconds. See it loading slowly. Any progress, Bill, at your end?
I can see it trying to load.
Okay.
There you go. Okay, Raju, take it away.
Got it?
Yep.
Great. Thanks. Sorry about that, everyone. So this is the DataRobot platform, and the way to use it is we could simply drag and drop a file or pull a local file, and I'll do exactly that right now. So this is the loan data file that Connor had prepared just now. In addition to pulling data into DataRobot through a CSV file that we are doing right now, we could also pull it from a Hadoop data lake if you have one, or even from a regular RDBMS type of database like Oracle or SQL Server and so on. Now, if you notice on the right-hand side, it is starting to load the data. And in a minute, it will load the data, and then it will start doing some basic statistical analysis where it will show you like the mean and standard deviation and so on for various columns. It's a bit slow than usual, so we'll give it a few seconds here. While it's doing that, let me explain to you a concept called blueprint that we will be seeing in DataRobot today. A blueprint is a concept where it's a workflow that involves handling various types of data In the data set that Connor had shown you, data is of numerical type, categorical type, text variables, and so on. So we need to handle that, handling missing values, imputing them, handling text variables as n-grams, bag of words, and so on. And then push these models into an algorithm that will make predictions. So this whole thing is called a blueprint, and we have more than 200 such blueprints. So what happens when you load a data set is DataRobot, based on the data you had loaded, will figure which blueprints to use. So many times it picks 30 or 40 blueprints and start running those blueprints against the data that is loaded. Okay, so do not know why it's taking so long. So let me give it a different try. Something is slow here today, Bill. Give me 1 second. Let me stop sharing my screen and see what's going on. All right, I think we should be good now. I'm sharing my screen again. Sorry about that. Hope you can see my screen now. I'm reloading the data. Yes, it's loading it right now. And on the right-hand side, you can see it doing its preliminary analysis. So we'll give it 5 more seconds. Okay. So it requires you to tell it what the target is. It's asking you to select a target to continue. So by typing here a couple of letters, I can pull which variable it is, and whether the loan was good or not. And it shows you a histogram of this variable where about 85% of the loans were good and about 15% were not the default loans. So the way we get started with this is by pressing the start button. Let me quickly show you a thing here called cross-validation. So DataRobot had made sure we have put some guardrails in place so that there's no overfitting. And with that, let's get started with the start button. So you'll notice on the right-hand side, now it's building cross-validation and preparing the data to be able to be fed to the blueprints. In a few seconds, it will start running the models. So we'll give it just a few seconds here. So it has, yes, it has finished that step. As you can see, these are all the blueprints that it will be running right now. And there is another option here where by pressing simply by clicking here, you can increase the number of workers so that it can run parallelly all of these algorithms. So these blueprints, once they start running, they will come into this place called leaderboard. The concept of leaderboard is where all your results are loaded here, and they are sorted, where the best models go to the top. So in a few minutes, it will complete these runs, and they will get stacked here. So what I did was, in keeping in mind the time for this webinar, I had already run this morning. So in this screen, I will show you results of what would happen when it completes the run. So the best models go to the top. These are some blended models where it's a combination of 2 or 3 models. But for today's analysis, we will look at a non-blended model. So I'll pick this one. So once you complete the run, you may want to see various details. So here what we are seeing is the blueprint that I was referring to earlier for this model, where data is taken, broken down into various types of data, categorical, numeric, text variables, and various steps are taken on them for handling missing values and so on. And all of this is fed into this algorithm. In this case, it's extreme gradient boosted algorithm. DataRobot made sure that everything we do here is transparent. So you can click on any of these rectangular boxes. It will take you to a page where you can read about the model, and you could even look at some literature out of which this model is built. If we go back here, you may also want to see how good your model is. And for that, you can look at things like a lift chart. The lift chart is where we take all the predictions and we stack them from the highest predictions to the smaller ones. Here in this case, it's 10 bins. And on the y-axis, we have the prediction probability for a loan to go default. As you can see, the actual line, which is orange, is matching reasonably well with the blue line, which is the predicted. There are a few other things that you can see in DataRobot. For example, this feature impact is where it can show you of all the features that were used to describe the loan, which ones were most effective in explaining whether a loan will go to default or not. As you can see here, interestingly, description, which is a free-form text that people can enter, is at the top, followed by annual income, interest rate, and so on. Let's see a little more on this description by going into the Insights tab here. And here we will see a word cloud where it has taken this description column and has color-coded it, where red, any word that's in red would signify a strong correlation to a loan that will go to default, versus blue indicates a good loan. As you can see, things like when people say borrower or business or even help me and things like that, those are bad indications of a loan, versus some blue ones here like pay credit card or consolidation seems to be good indicators. So let's go back here. And in the model we were looking at, there is one more interesting thing that I want to show you, which is feature effects. Sometimes you want to see what's the effect of each feature and see if you could maybe find some speed spots thereby in order to figure which loans to give money to. Let me remove the log axis here. So in here we are seeing income. So this shows a partial dependency. That means when you keep everything else constant but only vary the income, annual income of the applicant, how will the probability of the loan change? As you can see, as income increases above 100K, the probability of default is only at 10%, versus at some low incomes it can be 10 points higher. So these are various things that you can get out of DataRobot. And one last thing I want to show you here is how to make predictions. Once you build a model, of course you want to make some predictions, right? So you go in here and you could just drag and drop or upload a test data file. In addition, DataRobot also gives you a REST API. I will give you an example of that right now. This REST API is a web service. What you will be seeing now is a Python example, but you could use Java or any other language. So in this REST API, it's just a few lines of code, but it really helps when you're working with your IT because you don't have to wait for your release cycles from IT, but rather deploy this model and easily change it if you rebuild a new model as new data comes in by just changing the model ID. Okay? That concludes my part of the demoing. So we will pass this back to Bill now for Q&A.
Well, Raju, Connor, thank you for that great presentation. And we'll get started with today's Q&A. I'm going to move us to this screen while we do the question and answer session. And I want to thank the audience for their participation. We've had a lot of questions that have come in. So we'll do our best to get through all of them in the time remaining. And this screen also shows you the contact information for Raju and Connor in case you'd like to get a hold of them following today's event. So let's get started. There are a lot of questions around exactly who does what and what skill levels are required both in Trifacta and in Data Robot. So we've talked about broadly about this category of transforming data, but let me break it down into a little finer detail as a data scientist would. And let me ask these questions in sequence. So Connor, this first one, blending is obviously something that Trifacta does. So what skill level is required? Could this be done by a non-IT person? How many types of data sources does Trifacta support for blending? And what sort of volume limits might there be on blending?
Yeah, so the blending can definitely be done by someone who is not in IT. That's really the main driver of Trifacta's product, is making all of these transformation functionalities accessible to your average business user or someone less technical. Hopefully you saw a bit of that in the demo. I know it was somewhat short and interrupted by some technical issues. In terms of data sources, you can blend files, application data, databases, cloud sources, data warehouses. We've even got an SDK to build your own custom connectors. So really the sky is the limit in terms of what sources you can bring in. Data volume is also pretty much unlimited. It is dependent on the size of the platform that you're running Trifacta on. So if your platform can support gigabytes or terabytes worth of data, you can blend all of that in Trifacta, no problem.
Okay, thank you. Now, when I think about transforming, the second thing I think about is what I call data cleaning, which really means to me things like miscodes and dealing with nulls and that sort of thing. So, Connor, this seems to be clearly within the Trifacta's scope, and what skills would be required for the user to be able to bring data to that level?
Yeah, so really just the ability to open up the application and look at those data quality bars. The way that you start to see the bad records or the unclean records highlighted in red makes it super simple for someone to find those bad records. And then the predictive transformation, so clicking the bad records and looking at the suggestions that Trifacta generates for you. Really, if you can read the suggestions on the right, that's really the skill set that you need for this. So we do try to make the application as simple as possible and as actually have built in a lot of machine learning so that it'll come up with fully specified transformations for you without you having to code anything.
Yep, we saw that. That was really clever. So this next phase of data transformation I think of as the true transformation phase, and I expect, Connor and Raju, you're going to find some crossover between your two platforms here. This is the step that I would think of as dealing with, for example, outliers, removing outliers or detecting outliers, and also correcting, for example, skew in distribution of a particular feature. Whose platform does that, or do both of them?
So you can do a lot of that in Trifacta. So some of those histograms are what will allow you to quickly identify outliers. We didn't quite get into this during the demo, but you can do binning in order to, group values together. You can set values above a certain threshold to, a median or a mean. So a lot of that feature engineering work can be done upfront in Trifacta, and maybe that'll make having that engineering done before you run the model can often make the actual model itself more efficient.
Okay,
yeah, and the interesting thing,
go ahead.
Yeah, and the interesting thing on DataRobot side for handling outliers is it is smart in using the right algorithms when there are a lot of outliers, like trees and things like that, that are able to handle outliers inherently by themselves. However, there are options in DataRobot where you can click some buttons and see how much data is going towards the outliers. However, having it cleaned up front by a tool like Trifacta could always help.
Terrific. Okay, and then the final phase of this, I think of, and Connor, you already used this word, but I think of feature engineering as specifically creating new features from old. That is, for example, converting dates into day or month ranges, or taking ratios between different features. Again, it sounds like I can do this in Trifacta, but Raju, maybe this is something that automatically happens in DataRobot.
Yes, that's correct. And Bill, in addition to automatically creating ratios, differences, additions of features, and handling date and calculating day of the week and things like that automatically as features and as needed for only correlated features, DataRobot also makes it really easy for a domain expert to give in their feedback, because the results come out so quickly. You can build your first model and see that some of the plots that I have shown you, like feature impact and partial dependency, and get some new ideas, right, as you sit with your domain experts, and then say, this is looking a little different than how I thought it would be, so maybe we should create these features. Let's add that, and then see how the results will look next. And in our experience, running such experiments iteratively by getting feedback from your previous models can help a lot in building some of the best models that can go into production.
Well, thank you for that clarification. And we have time for just one more quick question, and maybe the one that is most on the audience's mind is for both of you, Trifacta and DataRobot separately, are these available strictly as a remote service, or are they on-prem, and are they run on my laptop, or do I need a high-performance cluster to do this with?
So for Trifacta, we've got a number of different editions. We've got a free product called Wrangler that works for files less than 100 megs. That can be run locally on your desktop. If you want more connectivity, maybe larger files, maybe let multiple people collaborate at the same time, we have an edition called Wrangler Pro. That's a cloud-based deployment, so either our cloud or your cloud. Azure, AWS, there's a Google Data Prep powered by Trifacta as well, which also falls into that category. And of course, unlimited processing, more users, SDLC-style operations, the connectivity SDK I mentioned, all of that, we have an edition called Wrangler Enterprise, which can be deployed on-prem in a large Hadoop environment, or also if you have, a cloud-based setup with, significant compute power, that can be installed there too. So lots of options.
Okay.
And
Raju, for DataRobot?
Yes. For DataRobot, we have mainly two options. The one you saw me giving a demo on is on our AWS cloud. So you could go for that option. That's one option. Or the second option, which is what a lot of our enterprise clients go for, is on-prem behind your firewalls, so your data doesn't leave your organization. And there we have, again, two sub-options, either to put it on your Hadoop data lake if you have one, or we could also install it on your Linux servers as standalone version.
Well, Raju, Connor, hey, thank you for some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Raju and Connor and the Trifacta team so they can follow up with you after today's webinar. Now, I have just a few quick announcements. If you'd please mark your calendars for June 26th, that's our next DSC webinar, which will be Embrace the Modern Analytic Lifecycle. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close, and I'd like to thank our audience for their attendance and thoughtful questions. A special thanks again to Trifacta for their sponsorship, and particularly our speakers, Raju Penmacha and Connor Carreras, for their insight into today's topic. Well, this is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on June 26th. Have a great day.